We have one last little topic here, and this is dealing with multi-step real-world problems. Those of you that have been in geometry have seen some of these. Some of you that are in physics or IPC have seen some of these. Probably not called an inverse function. It's basically just taking a function and solving it for a different variable, but it's the same process as switching our variables. However, when we're doing real-world problems, there's a very important thing to note. You do not, notice that's capitalized and underlined. That means it's important. Do not switch the variables. Okay, we are just going to take an equation and solve it for a different one of the variables. So let's take a look at an example. We want to find the inverse function that represents the surface area of a sphere. So surface area of a sphere, S, is equal to 4 pi r squared. So think about that for a second. If you switched around the r and the s, then suddenly r would stand for surface area and s would stand for radius, and that doesn't make sense. Don't switch the variables. But what we are going to be doing is solving for r. So we want to solve for r. Why do we want to solve for r? Because we want to find out what r is when we have an s value, a surface area of 100 pi feet squared. So let's go ahead and take a look at that. We're going to start with our original function, and we're just going to do our steps to solve for r. So I want to get rid of that 4 and that pi to start. And that'll give me s over 4 pi is equal to r squared. Now I need to take the square root. Let's use orange. Take the square root of both sides so that these cancel, and I'm left with square root of s over 4 pi is equal to r. Now let's think about that for a second. Normally at this point we would put in a plus and a minus in front of that square root sign, because when we take the square root of both sides we have to account for positive or negative values. But does it make sense to have a negative radius? Remember, radius is measuring a length. It's the distance from the center of a circle to the outside of the circle. So it makes no sense to have negatives. So let's make ourselves a note of that. Let's don't use the plus and minus, because a negative radius doesn't make sense. So sometimes whenever you are doing real-world problems, you have to put a real-world thought into it. There's no such thing as a negative distance. Okay, so now that we've solved for r, we can find out what r is equal to when s is equal to 100 pi. So we're just going to plug that in. R is equal to square root of 100 pi over 4 pi. Let's simplify this. Our pi's are going to cancel out, and 100 over 4 can be reduced to 25. And then if I take the square root of that, I'm going to get 5 feet. Square root of 25 is 5. So our radius is 5 feet when our surface area is 100 pi feet squared. All right, let's take a look at what might be a physics problem. So the distance in meters that a dropped object falls t seconds on Earth is d is equal to 4.9 t squared. Notice that we have a decimal starting out, so we're probably going to have a decimal answer. Solve the equation for t, so we're finding the inverse again, and then determine how long it takes for the object to fall 50 meters. So we're just going to start out like we've been doing. Again, don't change the variables. It makes no sense to call d equal to time, or vice versa, t equal to distance. So I want to divide by 4.9 on both sides. So d over 4.9 equals t squared, and then take the square root. Let me change colors here so you can see that's a different step. And so the square root and the squared will cancel, leaving me with square root of d over 4.9 is equal to my time. Again, don't use the plus and minus. Just like distance can't be negative, neither can time. Haven't found a time machine yet, so we can't go backwards and do negative time. T can't be negative. All right, so let's plug in for our particular case. So we are going to take our 50 meters here and substitute that in for d. So if we have our equation, t is equal to the square root of d over 4.9. We want to substitute to say t is equal to 50 over 4.9. And because we started out with a decimal answer is going to be perfectly acceptable. Just stick that in your calculator and you're going to get 3.2 seconds.